Hi, my name is Jesse Wells, and today I'm going to be doing quite a similar question to Chapter 8, Question 10. Now, this problem is basically outlining two factors that we're comparing to each other statistically and seeing, like, with their z-score, whether or not they correlate by, like, extreme factor, right? So, um, let's just say, right, that both sets of data are um, fairly similar. Now, if they both have similar sets of like a similar bell curve, which I guess I'll just draw right here, right? Where their mean and their outliers are pretty much the same. It basically shows that there's no like statistical significance because they're so similar that they have no correlational factor, right? So if we have like a high correlation factor, most of their data would show like outliers. So if one thing decreases, one goes up. If one increases and the other one increases as well, then great. But if there doesn't seem to be any change when introducing new factors, or that when comparing these two factors, they seem to not correlate any sort of way, then we know they're not statistically significant. So that's what we're basically testing. Um, so I have set up right here basic portions that we need to solve the problem, right? Which your example will give you. Basically, in how many people were actually in the study. We have our M being 5, our mean being 4.30, and our sigma being 1.20. Um, Basically, with all these different things, we can actually solve this. And so I'm going to be using these two problems on the bottom beneath the sigma, sigma m, and our z-score formula to solve this. So let's begin. We're first going to start with our sigma m problem, right? To solve this, will be sigma m is equal to our sigma, so 1.20 over the square root of our population. Whoops. That decides to not make it too smooth. So 16 divided by 4. Oops, sorry. 16 squared is 4. So this will equal 1.20 over 4, and then 1.20 divided by 4, which when we get a calculator out, 1.20 divided by 4 equal to 0.3. Then we'll do our z-score. Our z-score is equal to our x, which is our mean, 4.30. Which, sorry, I realized I didn't put the little bar over the x. So 4.30 minus r m, and divide that by our sigma m, which we got up here, which will be 0.3. And so when we do the calculation, it'll be 4.30 minus 5, which will be negative 0.7 over 0.3, and then divide by 0.3, we get negative 2.33 going on infinity. So now that we have this score here with our z-score, we're actually going to compare it to the critical region. We're going to find what value is needed to reject the null, which is basically to show that it is not common and there is actually an extreme correlation, whether it be negative or positive. And so when we look in the back of the book, right, we're going to find our sigma, um, what this value we're going to be looking for. So let me pull this up. Which I am just now realizing that I'm saying the wrong term. I mean to say alpha, which I realize is not right up here. That's why I got confused. Our alpha being, I'm just going to use the same alpha as the textbook, 0.5. For the value of 0.5, we find that the value to test whether or not it rejects the null is 1.96, positive or negative, and we got 2.33, which is greater than 1.96, even if it is negative. We're comparing it to like negative 1.96. So yeah, yes, it is significant. It rejects the null. So anyway, I hope that helps. If you have any questions with the problem, don't be afraid to reach out to either me or MK. Thank you very much.